Hello everyone. In this video, we are going to perform sentiment analysis on a given text. So the data is given to us in the form of a text file, and from that data, we are supposed to change it to a data frame, apply a text normalization, and then perform sentiment analysis. So let us begin. So before we begin over here, you can see that we are supposed to predict the sentiment of a given text and predict if that text is positive, negative, or neutral in nature. So let us begin by importing our libraries. So as you can see over here, I've imported pandas. So pandas basically help us to create data structures and manipulate them. So the data is read by the help of pandas, at the same time manipulated by the help of pandas. And then our second import over here is NumPy. And NumPy is a Python library which helps us to work with arrays. And not only arrays, NumPy also has domain over algebra and matrices, and NumPy basically stands for numerical Python. And over here I have matplotlib.cm. So what matplotlib.cm does is that basically matplotlib is a plotting library, and .cm over here stands for color maps. And then over here we have matplotlib.pyplot. So matplotlib is, as I said before, is a plotting library. And let us go ahead with our next import over here, which is the matplotlib RC params. So whenever matplotlib loads, it defines a runtime configuration, and this is the matplotlib inline. And what this really does is that it will make plot outputs appear, and it will store the plots within the notebook. And over here I've imported warnings. So this will basically ignore all such warnings which we get. And this is the other imports over here. Import RE over here. RE here stands for regular expressions. So regular expressions are nothing but they are a special sequence of characters that help us find or match with other strings or other set of strings. And then over here we have NLTK. So NLTK basically stands for Natural Language Toolkit, and it is our platform which will be used for building programs for text analysis. Okay, and then we have string over here. The string module contains a number of functions to process standard Python strings over here. And then we have NLP utils. So as I said before, NLP stands for Natural Language Processing, and NLP utils over here, it basically offers a set of APIs to work on strings such as names, sentence, paragraphs, and tokens, which are actually represented in an array of string or words. And what counter does is that Python counter is actually a subclass of dictionary class, and it basically keeps track of the frequency of each element in a container. So counter will help us to keep a count about how many times a particular word is repeating. And then we have imported stop words, and stop words are nothing but they are words which do not add any meaning to a sentence. Like even if we remove these words, they do not have any impact over the meaning of a sentence. Such words are called as stop words. And words included in stop words are like is, the, if, a, and so on. And then we have imported a WordNet lematizer. So basically when it comes to WordNet is nothing but it's a large, freely and publicly available lexical database for the English language. And when it comes to lemmatization, it offers lemmatization capabilities, as well as it is one of the earliest, and it is the most commonly used lemmatizers currently. And over here we have imported word cloud. So word cloud will help us to visualize our words. It is basically a graphical representation. It will keep the count of frequency of a particular word and give greater prominence to words that appear more frequently in a given text. So it will help us display most repeated words in a graphical way, and we'll see how this visualization looks like. And over here we have tokenization. I've imported sentence tokenization as well as word tokenization. So when it comes to tokenization, tokenization is nothing but it is a process of splitting a string or a text into a list of tokens. So they can be done in two forms. One is word tokenize and the other is sentence tokenization. And after that, we have imported TF-IDF vectorizer over here. So what TF-IDF vectorizer does is that it will transform text to feature vectors, which will be used to which will be infused as a used as an input to estimator. So after that, I've imported port stemmer, Lancaster stemmer, and snowball stemmer. So stemming is nothing but it is a process of reducing inflection in words to their root forms. So words like stemming will be transformed to their root word, that is stem, and that is what all these stemmers do. We can use any one of them. And then I've imported label encoder. So what label encoder does is that if we have a column which has a categorical variable in them, label encoder will encode them into numeric form, and that is done with the help of label encoder. So basically all the categorical features will be converted into numeric ones. And then I've imported train test split over here. So with the help of train test split, we will convert our data into train and test parts. And then I've used logistic regression over here. So logistic regression is our machine learning model, and this machine learning model will be evaluated with the help of our metric, which is our accuracy score over here. And then the data is given to us in a text file. So we read it with the help of this code with open text analytics.txt. So this is the text file, and once we read it, this is how the text looks like. It has around 999 lines of text, and then we begin with text normal